Today's video lesson is all about trend lines. So starting from scatter plots, which are graphs that have scattered dots, that's why it's called a scatter plot, because it has scattered dots, you would take a set of data. Let's say that we were taking a set of data comparing everybody's height to their wingspan. And if we were trying to figure out people's height to their wingspan, we might end up with some dots that look like these dots, kind of all over the place. Yet they're still forming some type of line, which we call a trend line. It's just like on TikTok or anything viral, it's the new trend. So if all of these dots are going in the same way, they are all trending, going together. That's why they're called a trend line, okay? Trend lines are the lines of best fit. You should have a paper that looks like this. That will be your notes for today's lesson. So first of all, let's look at some different scatter plots and talk about the different types of trend lines we can have. These are different types of association. Association means when two things kind of relate to each other. We had height and wingspan relate to each other just a minute ago. So it doesn't tell us what's relating on the x-axis or the y-axis. It just shows a bunch of scattered dots on a scatter plot, all in the same direction, which we can create a trend line out of. Now notice this says it is a positive graph because this is a positive trend line. So this type of association is a positive association. These dots are a little bit opposite. If I'm going to draw a line as best as I can in the middle of all these dots, it looks like these dots are trending downward. They are a negative association. I want you to point out this little guy over here, this little dot. This is called an outlier. He lies on the outside of all the rest of the dots. Have you ever heard of how if you get 1 0 out of all your good grades, it brings down your grade a lot? That is what an outlier does. So if you have all 90s and 80s and 70s and 1 0, it is an outlier. It brings down your grade a lot. So this little outlier over here, it doesn't do too much to the line since we have a lot of other dots, but it does make the line kind of pull towards it just a little bit, okay? Because we're still trying to put our line perfectly in the middle of all of our dots, all right? So if you ever see one of those out there, that's what it's called. It's an outlier. Doesn't really do too much, but we don't like them. And then if you notice that the dots do not create a trend at all, there is no trend, we call this no correlation. I want everybody to write these words with me. We call it no correlation, which is the same thing as saying no association. Whatever they were comparing, maybe they were comparing sodas bought versus candy bars bought. People can buy however many they want to of either of those. They don't associate with each other that much to make some type of correlation. A correlation means it kind of makes things go together. The more hours that you study for math, the less questions you miss on the test. That could be a correlation, a negative correlation. When there's nothing that relates to each other, when these things are not related, it's called no correlation. Pretty easy. So if you ever see a trend going up, it is a positive trend going down, negative trend, and then nothing. We also have something that we need to know that is the difference between scatter plots is some are linear and some are not. The ones we dealt with above are linear. This is a negative correlation. I'm trying to draw my line directly in the middle of all my lines, kind of showing the way that the graph should move. And then the nonlinear kind of looks like this. It kind of looks like it's forming that way, which is not a good thing. This is nonlinear correlation, nonlinear. This is a linear. And whenever I say not a good thing, I mean we don't really work with linear functions, with nonlinear functions in the 8th grade. So we don't see a lot of these. But sometimes they will say, which one of these are nonlinear? Well, it's anything that does not make a line. A straight line. Just so to be clear, okay? So, linear means line because it literally has the word inside of it. Nonlinear means not a line, not a straight line. Trend lines, let's talk about, so we were drawing trend lines earlier, but let's give it a formal definition. It says when a scatter plot is, when a scatter plot is graphed, a straight line can be drawn through the center or middle, whatever you'd like to write, of the dots to show the overall trend. So we call this a line of best fit. Down here, I'm going to write it. A line of best fit. And I'm going to box it, star it, circle it, something, but that is the biggest thing. This is a line of best fit. That is what trend lines mean. It is a trend of something. This is a positive trend. This is a positive trend also. However, only one of these is a correct trend line. The correct trend line goes through the center of the dots, which is this one. This is a line of best fit. The other one does not go through the center of the dots. It's kind of down. It's still going up. Yeah, so that's good. It is a positive trend. But the line is underneath the dots, which means that it is not a good fit. So we do not, this is technically not a trend line. Not a good fit. All right, let's talk about the ones below. So trend lines continued, as in this is something else that we can do with trend line. Trend lines can also be used to make predictions. So not only do we draw trend lines to see if it's positive or negative trends, but we can use them to make predictions. These predictions, if you predict something, that kind of means you see the future, or you see something that hasn't actually happened yet. It says these predictions are useful when the values are not on the scatter plot. So here's a bunch of dots right here, but we could find maybe some other dot could be around here somewhere. That dot could be there. We are predicting that a dot could be there because it's technically the right trend. All right. If we had to find the equation of this trend, we could use the dots to help us find the slope of the line. We know slope of lines. We also know y-intercepts are 90. So technically, if I were trying to find the equation of this trend line, I would change the m with the slope, the b with the y-intercept. Y-intercept is pretty easy to see. It's 90. So I'm going to say plus 90. I haven't figured out my slope just yet, but the trend line that they make pretty much goes through, I would say that's a perfect coordinate on the graph, and that's a perfect coordinate on the graph. So it goes from 90 up to 210, which is, I think that's 120. We're going to go with 120. So it looks like our rise was 120. Remember, I'm using my old kind of skills to figure out the slope. Rise over run. Up 120 over, and then down here it's not counting by those crazy numbers. It's counting by just regular 1, so over 6. 120 over 6 is 20. So it looks like it was going up 20 each time. 20 is my slope. I have now created an equation to my trend line. You would create an equation to a trend line after you see a bunch of dots, draw a line through the middle, and make the best prediction of an equation that you can. We don't usually work with equations of line too much. We mostly use it to make predictions, but this is a valuable key in case you need it. Or a valuable tool, sorry. All right, so the next thing says use the equation to predict the value when x is 20. So there's two ways to kind of help you make predictions. You can either use the equation that you make, or you can use your eyes and the line that you drew. So if we were looking for to predict the value of y would be here. When x is 20, that would be way out here to the side because we left off with x is 10. Now, we could draw this way far out. We could draw way out here, and we could try to predict what the y variable would be. But we don't have to. Since we created an equation for it, we can use the equation. And same thing with something smaller. So if we're trying to find when x is 20, what is y? If I replace the x right here with a 20, I would technically have 20 times 20 plus 90. 20 times 20 is 400. And 400 plus 90 is 490. Technically, our y value would have been 490. Now, 490 is way larger than these numbers here, so it helped us to use our equation of the line for this instance, because we couldn't draw that far on the paper. However, if you ever run across a thing that says predict the value of x when y, and I want everybody to change this right now, because I want you to find a number that is smaller that's actually on this graph. If it says when y, oh, actually I want you to say when y is, we're not going to do y is 6 because there's not even a 6 right here. When y is, let's say, 270. When y is 270, what is the value of x? Sorry, that took me just a second, but yeah, you're just rolling with it like I am. So if on the y side, on the y-axis, the y scale, if I go up to 270, I have to see where the trend line would fall on 270 as a y, and it would fall right about there. It might not be perfect, but this is a prediction, and predictions are estimates, they're guesses, educated guesses. And it looks like the x value that would be connected with the 270 would be 9. So 9 is the answer on this one. All right, and that is how we use trend lines to make predictions and to talk about association.